All right, let's do some factoring. The first thing you should know is that you should always factor out. This is always your first step. And what is factoring out? It's basically undistributing. So it's dividing something out of every term. And when I look at number 1, I can see that I could divide a 3 out of every term, and I could divide at least an x out of every term. So what I'm going to do is imagine that I undistributed a 3x, or divided out a 3x. And that would leave me with a 3x squared minus a 5x plus a 4. And if you're not sure about that, if that seems fishy, we could always distribute that 3x and make sure that we get back to the original thing. So that's the idea of factoring out. We want to look at all terms and see what we can factor out. In this case, an x squared factors out. And then we'll get to later, sometimes you can factor the rest of this stuff, but for right now we're just focusing on factoring out the greatest common factor. Number 3, what can we do? We can get a 4 out of all the numbers. We can get an x squared out of all the x's. So that'll leave me with a 4x to the 4th, a 3x squared, and then we put a plus 1 right here, because 4x squared divided by 4x squared is 1. And that way, if you redistribute that, you'll still have that 4x squared at the end. Last one for factoring out. I think the best we can do on this one is to factor out a 2. It's not much, but at least the numbers get a little bit smaller. Which, if then we had to factor the rest of that, it would make it a little easier just because the numbers are smaller, but we're not going to get there yet. Let's go to factoring by grouping. Factoring by grouping is a method that you would always use if you have 4 terms. If there are 4 terms, 1, 2, 3, 4, as in number 5. And what we do is called grouping because we are going to look at each of those pieces separately. So if we look at the 2x cubed minus x squared, what can I factor out of both of those? I can factor out an x squared, leaving me with a 2x and a negative 1. On the second part, I can factor out a 6, leaving me with a 2x and a minus 1. And these are always set up so that you'll see that nice matching factor right there, because the final step is where we look at these as 2 separate pieces and we think, what could I factor out of both of those? Well, I could factor out what they have in common, which is the 2x minus 1. And what would I be left with? I'd be left with an x squared from the first guy and a 6 from the second guy. And that would be my final answer. Most common question I hear is, why isn't that 2x minus 1 squared? Originally, there were 2 of those, right? Well, the reason is because when you distribute this again, when you take that and distribute it again, it will show up twice. So we really only need to write it once. We'll try another one of those. Anytime there's 4 terms, we're going to go with grouping. I can factor out an x cubed. I can factor out a 2. Coincidentally, both of those have an x squared minus 5 in common, with an x cubed plus 2 left over. Anytime there's 4 terms. Now on the second one, I could factor out a 3 or I could factor out a negative 3. I always let the first number take the lead. If that's a negative, I do factor out the negative 3, leaving me with a x and a positive. Nope. Yep, an x and a positive 2. And that works nicely because I have those x plus 2's in common now that I can factor out, leaving me with 8x squared, and a minus 3 as my other factor. Last one, is there anything I can factor out of a 6 and a 4? That'd be a 2, and I can take an entire x to the 4th out of there. 3x squared minus 2. Second one, the best I can do is just a 7. 3x squared minus 2, that's a good sign. They both have a 3x squared minus 2. And a 2x to the 4th plus a 7 left over. Great, that's factoring by grouping. We're going to talk about reverse FOIL. We remember FOIL, and basically the idea here is that the first, the outside, inside combine, and the last need to make those 3 terms. So I just set up a set of parentheses like this, and I think, okay, my first 2 have to multiply to make x squared. That's got to be an x and an x. And my last 2 have to multiply to make 15. I'm just going to take a stab at this, probably the 5 and the 3. And the reason the 5 times 3 works nicely is because when you do the outside inside now, do you see how the outside gives us a 3x and the inside gives us a 5x, which altogether the OI would give us an 8x. So that's a good sign. Everything's positive, so I'll just keep little pluses in there, and that would be my final answer. Sort of the shortcut thinking to that is that we are always looking for 2 numbers that multiply to make that last one and add to make the middle one. So if you can just think of 2 numbers that multiply to make 6 and add to make 7, you pretty much got it. And if you're thinking 6 times 1 makes 6 and 6 plus 1 makes 7, that's a winner. And if you don't believe yourself, you can try foiling that out, and it should go right back to there. Again, multiplying to make 21 and adding to make 10. 7 and 3. Gets just a little bit trickier with the negatives, so multiply to make negative 70 and add to make negative 3. Let's think about that. I'm thinking the 7 times 10 has potential. Which one of those would I want to be negative for them to add to make the negative 3? I'd want a negative 10 and a positive 7. If I added a negative 10 plus 7, I get negative 3, and then 7 times negative 10 makes the negative 70, so that works out. That's how I do it. I just kind of fill in the pluses and the minuses as they work. You could go ahead and try these before you watch me do them. I was thinking of 5 times 11. And then if we make the 5 negative and the 11 positive, that would add to make 6. And we'd still have them multiplying to make negative 55. A 4 times 2 to make 8. And if we make them both negative, it still multiplies to make a positive 8, but adds to make a negative 6. So that worked out well. This set gets a little harder, and it's all because of the number that is in front of the x squared. That just throws it a little bit. So let me show you what's different about these. This time when we do our first terms multiplied together, it has to make a 2x squared. So I'm going to have to go with like a 2x and an x instead of just an xx. And then my last 2 still need to multiply to make 3. But in this case, it actually matters whether you put 1 then 3 or 3 then 1, because you have to think ahead to that outside inside making a 5. So I am thinking if I try the 3 times the 1 here, everything's positive here, so everything would be a plus. Let me check the outside inside just to make sure that works. Outside I'd get 2x, Inside I'd get 3x, which does add to make 5x. So that was a winner. When the numbers get bigger though, we sometimes go to something called the AC method. The AC method is where, remember the quadratic formula, A, B, C. We take the A times the C, which in this case is 2 times 3. And then what we want to do is kind of like those previous problems, what multiplies to make 6 and adds to make that middle guy, the positive 5. And I think maybe you can figure out there'd be a positive 3 and a positive 2 would add to make 5 and multiply to make 6. So here's what happens. We kind of take that original guy again. We rewrite it, but instead of writing plus 5x, we split it into a 3x plus 2x because of those numbers that we came up. So that helps us split the 5x. The reason that works nicely is because now it's a grouping problem. What can I factor out of that first set? Just an x. What can I factor out of the second set? Nothing really, but I encourage you to factor out a 1 just so your brain can handle the next part. So we're factoring out a 1, it doesn't really do anything. But now do you see the two groups have something in common? The 2x plus 3, leaving the single x and the single 1, x plus 1. And we got the same answer both ways. They tend to refer this one to reverse FOIL or guess and check because there can sometimes be some guesswork involved. For example, on number 16, if you tried to just go straight into factoring this. So I'm pretty sure it's going to be a 5x times an x. That's really the only way to make a 5x squared. But then you have some options for the 14, right? You could go 1 times 14. And since the order matters, you might try a 14 and then a 1. Or you could try the 7 and the 2 and the 2 and the 7. Only one of those will work. And sometimes if you're not as well practiced, that can be a little more difficult. I'm thinking maybe the 2 and the 7 are going to work on this one. So let me try the 2-7 combo. The 2-7 combo. The reason I was thinking that might work is because I was kind of thinking ahead. That's a 35x and this is a 2x. I remember our goal of getting a negative 33. I can make that happen then. If your brain works that way, go ahead and use that method. Let's practice the AC method just in case your brain doesn't work that way. We're going to take the A times C, which is 5 times negative 14. They tell me that's negative 70. I want to think of something that multiplies to make negative 70 and adds to make negative 33. That could be a little tough. I think it's 35 times 2 though. And they have to add to make negative 33, so I'll put the negative right there. So those do multiply to make negative 70, add to make negative 3. So again, I'm going to take this dude and rewrite it, splitting the middle. So instead of that minus 33x in the middle, I'm going to split it with the negative 35 and the positive 2. So I'm just rewriting that original problem, splitting the middle, and then it becomes a 4-term grouping problem. You'll notice that my answer is in reverse order from my other one, but that doesn't bother me because I know multiplication, the order doesn't matter. So for all of these, it doesn't matter what order your factors are in. Worth trying another one of those. This one would be a real bear because there's so many things that multiply to make 12. You know what I mean? Like we could go 1 and 12, 12 and 1, 6 and 2, 2 and 6, 3 and 4, 4 and 5. But 3 and 4, 4 and 3. But if that works in your brain, absolutely go for it. The AC method takes the guesswork out of it a little bit. So a times c in this case would be 12 times 5, which is 60. Two numbers that multiply to make 60 and add to make that 23 would be 20 times 3 makes 60, but adds to make 23. Again, we are going to split the middle. That's the AC method, where we take that 23 and split it into a 20 and a 3, predetermined by this little method over here. And then just factor by grouping. This is one of those where I'll want to factor out a 1. Doesn't really do anything, but it reminds me that my final answer should have a little +1 in it. Great. If I were you, I would pause here and maybe try these yourself. Number 18. Moving on to special products, here's like a little box of sort of special factoring. Honestly, I have never really needed this one, and this one kind of comes from the methods that we used before, so I don't focus too much on those, but these last two are formulas that you'll need to work on figuring out, but let's just do some examples. These first two are of the same type, and the reason they're the same type is because it's a perfect square and a perfect square. 9 is a perfect square, 16 is a perfect square. So those are called difference of squares because of the minus there. Kind of the idea is you'd find two numbers that multiply to make -25 and add to make nothing because there's nothing in the middle. So a +5 and a -5 would work for this one. So when it's a difference of squares, you always just have 1 plus 1 minus, but otherwise they're the same term. And here we'd be thinking, what times what makes 9x squared? And that would be a 3x and a 3x. And then what times what makes 16? That would be a 4 and a 4. And as long as we make 1 plus and 1 minus, that'll do it for us. This next section is these are special, although they might not look that special, but what makes them special is perfect square, perfect square, perfect square, perfect square. So these are called perfect square trinomials. The middle term does have to follow a certain rule, but you can kind of do these just like we did the other ones. They need to multiply to make 9 and add to make 6. So x times x makes x squared. 3 times 3 makes 9. And when they add together, I get the 6. The reason this is called a perfect square trinomial is because those come out exactly the same. And so you probably wouldn't need to notice that ahead of time, but I do want you to write it as a perfect square at the end. This next one, maybe you'd use the AC method, but if you do, notice that perfect square at the beginning and perfect square at the end. It's worth trying this method. 2x times 2x, 3 times 3, and everything's positive in there. This one needs a double check. Does the outside inside actually give me the 12x? I do have a 6x and a 6x, so I'm going to go with yes. And so final answer on this one would be 2x plus 3 squared. So for these perfect square trinomials, it's a good one to know, but if you don't recognize it right away, you'll figure it out as you factor it the normal way. Number 25, I haven't done a good job of saying that. Remember that the first step every time you factor is to factor something out if you can. And on this one, you can factor out a 4. And then those are both perfect squares, yeah, the x squared and the 16. However, because there's a plus in the middle, we are not going to be able to use that method of difference of squares. Remember, those really only worked because they were subtractions. So I'm here to tell you that if you ever have a square plus a square, this part doesn't factor again. So this would be actually your final answer. 26, again, always want to factor out something first if you can. It'll make everything else smaller and easier to work with. Now this time, that's a perfect square minus a perfect square. They say difference of squares. So you would factor that one into an x plus 2 and an x minus 2. Make sure you leave that x on the front. It is part of your answer. All right. These guys might be kind of the trickier ones. We did do this in Algebra 2, but this is a perfect cube minus a perfect cube. Not everybody is as good with their cubes as they are their squareds, though. So did you realize that 2 cubed makes 8? That's helpful to know. 2 times 2 times 2 is 8. And that just means that we are going to be looking at this little formula right here. It's a formula for factoring. And so I am seeing an x cubed minus a 2 cubed. It helps me just to write down a is x, b is 2. And once you can identify what the a and the b are, you are literally just going to use this formula to factor it. So the formula says I'm going to have 2 factors. The first one is going to be the a minus the b, and the second one is going to be the a squared plus the a and b multiplied plus the b squared. When I said formula for factoring, I meant it like that's your final answer. The second part, if you're using difference or sum of 2 cubes, it never factors again. You are going to need to memorize these 2 formulas. We didn't make you memorize them in Algebra 2, but now it's college, so we're gonna go all in. You should memorize those. It's probably just gonna take some practice. On number 28, I don't know if you would recognize this, but that is a perfect cube minus a perfect cube. 3 cubed is 27. So in this one, I'm going to be thinking of my a as 2x and my b as 3. And it looks like I chose another -1. I probably should have done a +1. So we're going to use this top formula again. Had it been a plus, we would have just used the sum of cubes. So the little formula goes a minus b. So our first factor is 2x minus 3. Second factor is the a squared. This is tricky for some people. 2x squared. It's also known as 2 squared x squared, so it's actually 4x squared. So when you see in the formula a squared plus ab plus b squared, the a squared part is 4x squared. Plus the a times the b is 6x, plus the b squared would be 9. And the good news is you're always done after that step. And then I am going to let you do these as sort of homework, 10 problems, and then when you come back, we'll check those and see how it went. The challenging part here is that all of those methods are kind of mixed together, so you'll want to remember that we always factor something out first if we can. If there's 4 terms, we'll want to use grouping, and otherwise you might recognize some of those special products. Try it out, see how it goes.